Hi everybody, and welcome to the next video on loops. So in this video I will introduce the other kind of loop that we'll be using in the semester called a for loop. So now that we're comfortable with while loops, the for loop material will go quite a bit faster simply because you're already comfortable with the idea of a loop. Once you have the concept of a loop in your head, then learning about a for loop is more an issue of syntax rather than some sort of conceptual learning. So what I want to do is just show you the syntax of a for loop and the mechanics of how they work, and then just give you several examples. So in this video, I want to introduce the concept of a for loop, show you a bunch of examples, and since we already have a while loop, I want to spend just a little bit of time talking about why even have two different kinds of loops. So here's the motivation for a for loop. Many computations, many programs, involve processing the characters of a string one character at a time, processing the elements of a list one element at a time. So somebody gives you a list of homework scores, right? And you just want to one by one do something with those scores. Maybe you want to add them up. Maybe you want to sort them. I don't know. Processing the lines of a data file, right? So suppose you have a data file with like 2 million lines of data in there, right? And you just want to go line by line and do something with it. So who knows? Record each value and then average at the end or something. Okay, those sorts of computations a for loop is built for. So basically the syntax of a for loop and the mechanics of how they work are built for this kind of thing. So I should say a while loop can also do this. We have used a while loop to do things like this. So for example, we've used a while loop to go through that homework score list from a previous video. So a while loop can do this also. It's just that the syntax of a for loop is friendly for this kind of like traversal task, for going line by line through a data file, going one at a time through the elements of a list, whatever. For loops are sort of built for that. Okay, so before I show you more sophisticated examples, here's a first example of a for loop. Here's the syntax. For k in range 4, colon, print k. Okay, so let's unpack what's going on here. K is a variable that this for loop has called into existence. Okay, this loop has created a variable called k. In range 4, what that means is that k is going to start at 0. If you use this range command with just one number, that's where the variable always starts. It will start at 0, and then you will go up to 3. You always stop right before this number. And then all I have the loop do is print k. So k starts at 0, then k clicks up to 1, print, clicks up to 2, print, clicks up to 3, and then does click up to 4, but then you stop. Okay, so here are the mechanics of a for loop. First of all, you have this variable that the for loop creates. So I used a k here. You can use any letter you want, or really any word you want, as long as it's not a reserved word like while or something. So whatever letter you write there, k, I, j, whatever, the for loop creates that. It then advances through that number one at a time, right? So k becomes 0, k becomes 1, k becomes 2, etc., until you tell it to stop. You do whatever it is you're supposed to do over and over again. Once the loop is done, this k value just sort of pops out of existence. So this k variable exists only within this loop. So later in the program, you can use a k, and the program won't be confused, right? There's no double naming going on, because once this for loop is done, k disappears from memory. So the computer just wipes that k out of there. So this is how a for loop works. You can see how it's sort of built for transversing or for just increasing a counter variable here. So nowhere in the loop did I have to write a command like k plus equals 1. I didn't have to tell the loop I want that to happen, because for loops are built for that to happen. If you're going to use a for loop, the syntax is built so that this k just does that for you. It starts at 0 and then works its way up to wherever you tell it to go. Yeah, so again, the variable k is created specifically for this loop. Once the loop is done, k is done. Okay, here's another one. For k in range, now I give it 2 values. Notice 1, 4. Now k will start at this value, 1. And it will end just before this value. So it's kind of obnoxious, but when you give a for loop a range of values to traverse over, it's inclusive on the left. It will start at this value. It's not going to start at 2. It starts at 1. But it's not inclusive on this right-hand value. Okay? So it stops before 4, just before 4. Okay, so let me just show you another example. Let's write a program that lets the user enter a whole number n. The program calculates the sum of the first n whole numbers. So for example, if the user enters 5, the program does this computation, 1 plus 2 plus 3 plus 4 plus 5. And the program will calculate 15 for you. If the user entered, say, 7, you would do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, whatever that is, 28 or something. Okay, so here's that schematic. Just to save time, I'm not going to jump back and forth between the slides and the compiler. But anyway, here you go. So number equals, give me your n value, right? So whatever the n is gets saved as number. You then create this sum variable that will let you sum over all these numbers. And then I say for m, so again, you can use a k, I, j, whatever. For m in this range, 1 all the way up to number, right? So if I get to number plus 1, I don't do anything. Okay, so again, it's not inclusive on this, so I will stop at number. What I'm going to have happen is sum is just going to equal itself plus m. So initially, right, m starts at 1 and sum starts at 0. So this line of code here increases sum by 1. So sum becomes 1. Then when m becomes 2, the sum increases by 2. Well, it was already 1, wasn't it? So now I'm doing 1 plus 2. Then m becomes 3. And so now I'm doing sum increased by 3. So sum was already 1 plus 2. And now I tack a plus 3 on the end, etc. Okay? So just all the way up to, say, 5 or 7 or whatever number the user gave. Okay, so here's a nice way to just add a bunch of stuff up. We added a bunch of stuff up with a while loop also. But notice, right, this is just sort of cleaner or something, you know. You don't have to write inside the loop that you want m to increase by 1. Okay, for loops assume you want to do that. So they save you a little bit of the trouble. And then if you want to, you can print that sum at the end. Here's another example. Suppose, as in previous examples, like from previous videos, you have already in your back pocket a list of homework scores called HW scores that you or the user has built, whichever way. If you want to calculate an average score, for loops are nice for this because they just nicely iterate over things one at a time. So here's how that goes. So total initially will be 0. And then basically just like the sum example before, total plus equal whatever you're currently looking at. And notice how this for loop lets you set it up. For score in homework scores. When I say this out loud, it sounds like I'm about to start the Gettysburg Address. For score, right? So score here doesn't have to be a letter. Basically, homework scores, right? That's a list of homework data, right? So I have in there, 20, 25, 30, whatever my homework scores are, right? This guy here will just range over those. It'll start at your first homework score. So 20 maybe, right? So total becomes plus equal 20. Then it goes on to the next item in the list, then the next item in the list, etc. Okay, so here notice, right, we did this task with a while loop, but we had to set up like a dummy variable that traversed over the homework scores. We had to worry about not going past the end of homework scores. We had to worry about the length of that list. We had to worry about a bunch of things. For loops, though, just like they assume you want to do this kind of thing, so they don't make you worry about such things. So anyway, this sort of dummy variable here, the score, would just range over all possible elements of this list, all possible scores, just one at a time. They get added to the total. And your average then is just a total divided by how many homework scores there were, just like when we did this before. Okay, so again, if you have a list, homework scores is a list, and you want to just one at a time go over the things in that list, a for loop lets you do it pretty nicely, just like this. For, and then whatever word you want there, right? It'll be context dependent. For score in this list of scores, just like deal with them one at a time. Okay, so recall the prime number checker from last time, right? The way that worked was that I started at the number 2, worked my way up through n-1. I did that one at a time. I went from 2 to 3 to 4 to 5 to 6, checking for possible divisors. So when you want to check things one at a time like that, again, you can use a while loop, but a for loop is kind of nicer. So here's the code for that. It's similar to what I did before, you know. So prime, I assume the number is prime at first, and then for k in this range, starting at 2, and then again, I'm not inclusive on this, so I'm going to end at n-1. If this number here, when I divide by k, there's no remainder, that means that I found a divisor, so the number is not prime, therefore prime is false, and then I can break out of the loop just like last time, and then if prime is true, your number is prime, etc. Okay, so this is basically the same as last time. It's just a little cleaner. So last time I actually had to take this k variable, which I called x in the other slides. You can call things whatever you want. But anyway, so I had to actually, in the loop, increase x by 1, you know. Otherwise, I'd have to worry about an infinite loop. I had to create x up here and start it at 2. Notice this for loop is just sort of collapsing those tasks for me into a single line of code. So if I were you, I would compare this code here to the code from last time and acknowledge that this is cleaner. You know, the for loop here really is doing things for you better. It's easier to read, it's easier to implement. Okay, I think I have 2 more quick examples for you. Example 6, let's say you've gotten a list of exam scores, and we'll call it exam scores, from the user. So the user has given you, hey, on exam 1 I got a 78, on exam 2 I got an 85, whatever. They've told you all that, and you've saved that data in this list. Let's write a program that will see if the user ever got 100, right? That's a nice score to get. And if so, the program can like high-five you or whatever. What does that look like? Okay, so same kind of setup as before. I'll just assume I haven't found 100, right? Finding 100 is kind of a, low probability event. And then I'll just iterate over that list for score and homework scores. Well, if the score equals 100, hey, found one, right? So I will record that. Found 100 is true, and then I can stop looking. Right, so this is eerily similar to this one, right? Eerily similar to this one also, right? You just go over these scores. So anyway, if found 100 is true, right, because you found one, so you made that recording right there, congrats, you got 100 on at least one exam, right? So notice, maybe you got more than 100, who knows? I'm not recording that. Otherwise, may want to check with your advisor about dropping the course or something. Anyway, so this for loop makes this kind of task here pretty straightforward. Just you got this exam data. I just want to check the exam scores one at a time and see if, just check something about them, right? In this case, checking if there's 100. You could check to see if the user failed any exam, right? So you could change this condition to be score less than or equal to 58 or whatever the fail number is, Okay, so lastly, this is the most complicated one, but I figured I'd show you one more sophisticated one just to get an idea of what could arise and what for loops can do. For loops are nice for counting. So, for whatever reason, suppose you want to know the number of times the word the appears in a string, you can use a for loop to do that task for you, okay? So if you think about what needs to happen here, the user has given you a string. And that string, by the way, if you're reading it from a file, that string could be an entire novel or something, right? And so this kind of like word count analysis people sometimes do for famous authors, right, to figure out what their go-to words are. And so, of course, the word the is boring, right? But, maybe you have, you want to see how often Faulkner uses, I don't know, whatever words you think he's into. I don't know what he does. Anyway, you can just sort of like iterate over the string using a for loop like as follows. Now, before I show it to you, I should say this task is actually more obnoxious than it first appears because you can't just search for the letters THE because those might appear inside of a bigger word like there, THERE. And if the THE appears inside of there, you wouldn't want to count that as a the appearing, right? So if you think about trying to count the number of times the word the appears, not just like the string the appears, you're going to have to search for the where there's spaces on either side of it. Okay, so you're actually not really looking for the, you're looking for space, the space. You see? Otherwise, you might pick up words like there or they, right? They, and you don't want to count those as hits. Okay, so first we get a phrase from the user, tell me something, man, and they enter it in, right? And I create a variable to keep track of how many instances of the there are. And before we dive into this loop, notice it's kind of complicated looking, but the reason is because I need to search for things that look like the space at the beginning of the phrase, right? So if k equals 0, I'm at the beginning of the phrase, right? I haven't gone anywhere yet. The phrase might start with the. If it starts with the, there's not going to be a space on the left because that's off the page or something, right? But you might start the and then space on the right. Similarly, the user might decide to end their phrase with the word the, in which case the phrase would end space the. Now, who knows why they would do that, right? But it's possible that they decide to end their phrase with the and then stop. And if they stop at this there's no space on the other side. Otherwise, though, you do need to search for space the space, or the capital version, right? Space the space. Okay, so what's happening here is k is keeping track of where you are in the string. So you're going to start at position 0 and then go up to position 1, position 2, etc., right, all the way to the end. And notice I actually don't go all the way to the end of the phrase. I quit 4 characters too early because, you know, if you go all the way to the last letter, at the last letter, there's no reason to check for a the, right? The last letter cannot be the word the, right? This is as far as you have to go, the last 4 characters, just to check if for whatever reason the user ended the phrase with space the. Okay, so what's happening here is, at the beginning, right, if k is 0, then hey, tell me if they started their phrase with the or the with a capital T, right? And I'm looking for something of length 4, right? So this phrase, k colon k plus 4, recall what this is. If k is 0, this is a 0. This is a 4, right? So as with the range on a for loop, right, I'm inclusive here. So I'm going to start at position 0, but I'm not inclusive there. I don't go all the way to 4. I stop at 3. So this looks like 0, 3, right? Positions 0, 1, 2, and 3. So I'm checking position 0, 1, 2, 3. Does it look like these 4 characters? Or position 0, 1, 2, 3, these 4 characters? And if so, right, if the phrase starts with a the, then increase the count by 1. Otherwise, if k is at the very end of where I want to search, then hey, tell me if those last 4 characters are this or this, and if so, increase the count by 1. Otherwise, you know, I'm not at the beginning, I'm not at the end. Tell me if the 5 characters I care about, right? Because now I got space on either side. So tell me if k all the way up to position k plus 4. So there are 5 characters there, right? There's k plus 1, k plus 2, k plus 3, k plus 4. Those are 5 positions inside the string for 5 characters you're looking for. Tell me if those 5 characters are either the with 2 space on either side or the with 2 space on either side with a capital, right? And for some reason it's not showing up. Sorry, I don't know what's happening right here. There's no trickery here, right? These are correct. For some reason, I'm not sure why it's not showing up now. It was earlier, but there's supposed to be a k plus there. K plus 4, k plus 4, k plus 5. Starting at k, going to k plus 4. Starting at k, going to k plus 4. Starting at k, going to k plus 5. Sorry. Those showed up when I opened these earlier, so I don't know what happened to my code that makes these. But anyway, so here's a more sophisticated example of using a for loop to iterate over a string. You can search for things, right, or count the number of times something appears inside of a string. Okay, so at the end of this video, you should be comfortable with the syntax of a for loop, the mechanics of a for loop, how they work. You should also be comfortable with the idea that for loops and while loops can essentially do the same thing, although while loops are actually a little more powerful because for loops really are built for this kind of task, right? Just one at a time go through something, whether it be a string or a list, for loops are built for that more specific task, okay? But for loops and while loops are sort of, two sides of the same coin. They're trying to do the same thing for you. For loops are just built syntactically for this more specific task of iterating over a list or just iterating over a range of numbers. You know ahead of time that you want to start at 2 and end at n-1. A for loop is built to just make that go easier for you. There's less typing for you, right? The syntax is more suggestive in English, what you're doing, etc.